Hello, everyone, and welcome to Edge of Things. My name is Serena, and joining us today is Mark and Kutzai, who will be presenting their topic on Edge AI systems compatibility with MQTT, and Sparkplug. If you have any questions for them throughout today's presentation, feel free to ask them in the chat or use the Ask a Questions tab. Without any further delay, Mark, Kutzai, over to you.
Thank you, Serena, and welcome everybody. So yeah, as Serena mentioned, today the topic that we're going to be covering here is Edge AI system compatibility with MQTT and Sparkplug. And to help talk about this topic, I'm joined by Mark. Myself, I'm Kutzai Manditeresa. I'm a developer advocate at Hive MQ, and I'm an Industry 4.0 and IoT evangelist in general. So, Mark, I'll pass it over to you to introduce yourself.
Thank you, Kutzai. So yeah, my name is Mark Pose. I'm developer advocate at Balena.io, and I'm as well working on partnerships at Balena. And yeah, happy to help on this demo. I'm a big fan of MQTT, so happy to show to everyone how we use MQTT on Edge AI.
Awesome. Yeah, so the agenda for this session today, we've just gone through the introduction, and then after that we're going to go to into the details about these standards of how to integrate MQTT and Sparkplug within Edge AI systems. And then after that, Mark is going to show us a demo of exactly how that looks like in practice. And it's going to be a fully integrated pattern. So we are going to understand what that means shortly. And then after that, we're going to go into Q&A. So we've got quite a lot to cover. So without further more to do, let's jump right in. So, the assumption generally throughout this talk here is that you have an understanding of what MQTT is. So I'm not going to go into detail about what MQTT is, but just for the benefit of those who want a brief introduction to MQTT, it is basically an IoT communication protocol that uses a publish-subscribe mechanism of information exchange. It is an open protocol, lightweight, report by exception, and it is also edge driven, which really allows you to build some event driven solutions out of it. And again, as mentioned, we're also going to be really covering two aspects of MQTT. So there's flat MQTT, or some call it vanilla MQTT, and there's also MQTT Sparkplug B, which is the current iteration. So for those of you on the call who are not familiar with Sparkplug, Sparkplug is a specification that was written on top of MQTT to aid interoperability, specifically in the industrial automation or industrial use cases, and how that does how Sparkplug does enable that interoperability is through three key aspects that it addresses. First of all, it standardizes on how MQTT topic namespaces are represented. So for those of you who are familiar with MQTT, you would know that it's really flexible as to how you could structure your MQTT topic namespace. So what Sparkplug does is try to kind of like standardize on a consistent way of representing elements within an MQTT topic namespace. And the other thing that Sparkplug does is it really handles the state management. So as you would know, MQTT has last will, right? Which but not every application implements that. So the idea with MQTT Sparkplug is to first leverage that last will and testament with what are called death messages, so that you could actually detect when a participant leaves the network. And then in addition to that, Sparkplug also creates the concept of the end path, which really allows all participants within an MQTT network to be able to announce themselves whenever they join the network, and so on and so forth. And then the other aspect of it is the payload structure. So again, as you would know, MQTT is purely a byte stream, a byte array, right? And it doesn't really have a structure to it. So the other aspect that Sparkplug does is kind of like come up with a consistent way of structuring MQTT payloads using Google protobufs. So this is what Sparkplug adds on top of MQTT. So we're going to cover both flat MQTT and Sparkplug on how they can be interchangeably used within an Edge AI ecosystem. And of course, Sparkplug is in the good hands of our friends from the Eclipse Foundation. So if you need some more information about that, you could follow the link that's on the screen there to learn more about Sparkplug. So now, why is first of all, just to kind of like talk about why MQTT is so attractive in Sparkplug for solving some industrial data integration problems that currently exist. So traditionally, how data is exchanged or integrated between different systems is through some proprietary SDKs or some dedicated APIs that you need to integrate between an application and a device. And what that does is that if each and every application needs to maintain a dedicated connection to each device from which it needs to get data, what that end up doing is that it creates this complex architecture, which is first of all really difficult to manage, and it is not scalable, right? So and it really does not allow you to kind of like use the best in class tools, because applications become dependent on the devices that they control. You can't select a device based on whether you know it is the right kind of job. So that's why we've seen over the past few years, we've seen MQTT and Sparkplug gaining sort of like popularity within the industrial space because of this ability to kind of like really break down that complexity and break down those silos, and rather create this centralized repository of exchanging information, whereby, as opposed to having one application having to maintain and understand, say, 100 different API interfaces, it only needs to actually connect to one common endpoint, which is the MQTT broker that contains information from all these different applications, which really simplifies integration, which also opens it up for you to be able to kind of like plug in different systems into your infrastructure and kind of like really decouple that, which makes it easy for you to integrate your system, which makes it easy and fast for you to really solve the problem that you come across, because then you've got all your data centralized in that one repository of information. And you might have come across this idea of a unified namespace, which is the idea that as you bring in these different systems, whether through a gateway or maybe they natively talk MQTT or Sparkplug, they're able to publish information into this central repository of information, which is the MQTT broker. And then within the unified namespace, what that MQTT allows you is that it allows you to sort of like create a directory or a structure, an information model within the MQTT broker itself using the MQTT topic namespace. And also the payload itself then becomes the actual object that sits within that directory, that makes it easy for you to find the information that you're looking for. So this idea of a unified namespace is this idea that you could structure the directory of your information within the MQTT broker based on how your organization is already structured. So typically you'd follow the ISA 95 common data model of saying enterprise, site, area, line, and cell, and then you can then have different objects of information live at different levels within that hierarchy based on what makes sense within your organization for that information to live. So most of what we're going to be talking about, and also really what inspired the work that we did around the standardizations of Edge AI data interchange within MQTT and Sparkplug, is to be able to then fit it into a unified namespace architecture, right? And because this is kind of like really the architecture that is becoming clearly the only commonly acceptable like standard, like a methodology, because what we have in industry right now is really products that are like vertical integrated products. So there hasn't been up to now a common or an open ecosystem where you're able to really build your industrial IoT solutions on top of, just by plugging different things using an open standard like MQTT and Sparkplug B. So now let's kind of like really talk about why did we really come up with. We'll talk more about what that is, but first of all, why did we find it necessary to standardize how edge AI systems exchange information within MQTT and Sparkplug? So as I mentioned again, MQTT and Sparkplug have really been becoming predominant within the industrial space. So now we need to kind of come up with a way of exchanging information within the industrial and manufacturing environment itself. But again, as you would know, a lot of value with AI, as far as manufacturing is concerned, is really within the factory itself, because this is where the source of information is, and this is also where a lot of results from edge AI inferences need to be implemented. For example, if you want to perform anomaly detection and you want to be able to close the loop, or you want to be able to notify production manager or whoever is responsible, all of these different parties are within typically a manufacturing environment, right? So you want to be able to perform those inference and kind of like closing the loop within the manufacturing environment itself. But again, there's so many reasons why AI is moving from the cloud to the edge, specifically for manufacturing. There's issues with latency, there's issues with data ownership, there's issues with security. So there's a whole host of issues that are really making a lot of companies want to bring their edge their AI workloads into the edge, into the manufacturing environments. So now, because you've got all these edge AI systems that are exchanging information within a manufacturing environment, you need to come up with a way of enabling interoperability between these systems that are using MQTT to exchange information, right? And this really makes it flexible, again, to the point that I mentioned earlier, for you to be able to plug in an edge AI system from one vendor into an MQTT, so Sparkplug infrastructure, and have the result or the inferences that it is producing be understood by an edge AI system of another vendor, which is vendor B. So this idea of interoperability is really what drove us to kind of like come up with this a way of standardizing how these results from AI models are exchanged within an MQTT and Sparkplug network. And obviously what that does is that it really saves on cost, because in many cases, if a company is to kind of like come up with a way of integrating these different systems on their own, it means there's a lot of research and development that needs to go into sort of like laying that foundation of exactly how the system needs to communicate with this system, and maybe developing some proprietary connectors just to be able to make these two systems communicate with each other. So there's a really huge cost saving as far as coming up with a standardized way of exchanging information there. And obviously this accelerates development, and really it makes the system to be able to be scalable, right? Because this, you could replicate it across different plants, and also you could keep on adding many more participants into your network without having to worry whether they are going to interoperate with each other or not. And obviously this also again encourages innovation and enables innovation, because now instead of worrying about how you are going to integrate your system into the rest of the ecosystem, you can really focus on what problem you're solving. You're able to kind of like identify a problem and be able to iterate and experiment within that ecosystem, because you already have access to how information is already exchanged. You already have access to all these inferencing that is being generated by the different models within your network. So this is really why we thought it was crucial to come up with this standard. And so most of what we're going to be talking about here is available on GitHub. So this is an open project. So again, as you saw here, this was first of all initiated by myself, and also a couple of folks from Mozi and also Oshkosh Corporation, and we put it out there. But we've since been joined by Marcus from Balena, and we're also open to the rest of the community to keep on adding to this. This is really an open source initiative, and we encourage everyone to kind of like really also participate here and be able to add into this. So we will share the link with you if you want to kind of like access that. So I think we've spoken too much about what surrounds the standard itself. So now I think it's time to really dig into what that looks like, what the standard looks like. So when we looked at how the current infrastructure, industrial infrastructure, and exactly how systems currently exchange information within an industrial environment, what we came up with is an identification of 3 patterns, as it were. So there's one pattern whereby you've got an AI model that is consuming information from sensors through MQTT, performing that inference, and then publishing its result through MQTT again. So it's MQTT in and MQTT out. This is what we called the fully integrated pattern. And this is what Mark is going to be demonstrating for you later on. And then the other pattern that we identified is a situation whereby the model is actually receiving information through some dedicated field bus protocols. It could be, so maybe it's receiving information via an MQTT interface. So maybe it's getting information from a robot arm or whatever equipment that is exposing its information through an OPCUA interface. And then it's performing inference on this specific set of data set that is receiving. And then it is publishing its output through MQTT. So this is what we called an unstructured data pattern, right? And then we also identified a situation whereby the model is receiving information or data through MQTT, and then it is performing inference and then publishing the result through a dedicated field bus protocol. So this is a situation, for example, where say a model has received this information about an action that needs to be performed on a robotic arm. So again, instead of sending that information through MQTT, you want to have that synchronous communication where you're able to control the robotic arm. So this is where really field bus communication protocols are best suited for. So you want to be able to ingest information using MQTT and then be able to perform or close the loop using a dedicated protocol. So this is again what we called the ambassador pattern. So these are the 3 key patterns that we identified as far as what we'll need to cover in standardizing on how edge AI systems exchange information within an MQTT network. So again, to kind of like really go into detail about what that looks like in practice. So this is the fully integrated pattern. So again, here the idea is that typically you'd have an edge device. So an edge device, so this could be a simple Raspberry Pi, or it could be like really a big, powerful edge device. And inside that edge device, you could have more than one model, right? That sits there. It could be one model, or it could be more than one model. So this is what we accounted for when we thought about this. And then you'd have an MQTT broker, obviously at the center of everything. And within the fully integrated pattern, again, as you see, you've got your audio, video data, or machine data being published into the MQTT broker. And you've got an MQTT client within the edge device that is then obviously consuming that information into the different models, right? And then once that whatever model is performing the inference within the edge device is then publishing that information back into the MQTT broker in a topic where it will then be received by, it could be a feedback control mechanism, or it could be for storage in a database, or whatever the case may be. And the idea of really coming up with these different AI models is that kind of like want to reflect that reality on the shop floor, where you could have more than one AI model within a device. So you want to be able to determine, as far as structuring the topic, you will see later on how exactly we would be able to account for that. And then there's also situations whereby this information is coming out of a machine where you have got no control over the payload itself, right? And whereas the AI model expects that information in that specific standard that we defined. So this is where you also are able to plug in a data transformation layer, which is basically a layer that subscribes to the MQTT broker, consumes this information, which is in a raw format, as it were, contextualizes it, and then republishes it back into the MQTT broker in a format, standard format that we defined, that is understood by the AI models so that the AI model itself doesn't have to take care of that workload or that cognitive load, really, because this is an acknowledgement or a recognition that not every system is going to be able to give you that MQTT message in a structure that we defined or that we expect, right? So this is what the fully integrated pattern looks like. And this is the unstructured data pattern. Again, it's got the same setup where you've got an edge device, different edge AI models, but now the difference is that the inputs are coming through a dedicated protocol. So it could be HTTP, OPC, whatever the protocol is that is providing that information for the AI model to perform the inference, and then it will generate insights and publish those insights into the MQTT broker. So again, you've got different systems that expect to receive that information. So again, the idea is to standardize on this information that is coming out of the AI model. So previously we're standardizing on information that is coming into the AI model and out of the AI model. And then this is the ambassador pattern, where the standardization really is on the information that is coming through, in the input that is coming into the MQTT broker from all the different systems. Again, here, as I mentioned, you also need to have a data transformation layer because you don't have control over the payload. And this information goes into the AI models, and then the models perform the predictions, and then they publish those inference or insights or feedback control loops via a dedicated protocol. Again, this could be a field bus protocol that is really well suited for controlling, say, a robotic arm or whatever the case may be. So this is basically the whole setup and idea and what we thought about to would be necessary for us to cover within this topic structure and payload design. So first of all, let's look at the guidelines that we came up with as far as the topic namespace itself is concerned. So the first realization really was this idea that we're going to need to have different namespaces to hold this information as it comes into the MQTT ecosystem from all these different edge AI systems. So this is where we identify the idea where we've got the raw data namespace, which is basically a namespace that is meant for holding the raw sensor information that is captured from the machines. And then we've got an inference namespace. So now we've got the raw namespace, which is the data that is coming from the machine. The AI model consumes that, it performs an inference, and then it publishes that information to an inference namespace. But an inference namespace is just that, it's an inference, right? So an example would be you've got a camera system that is supposed to detect how many people are in a work cell, right? In a work cell. So an inference in this case would be we've got 5 people in that work cell, right? So that is an inference. And then, but you still need to have an insight. What does it mean for in a business context, right? This is where it could be that maybe there is rules within the business to say you only want to have, say, 2 people at any given time within that work cell. So this is where that insight then needs to be published into an insight namespace to say this is an anomaly, or this is a fault, or this is a sort of like a breaking of the rules, as it were, right? So now you need to kind of like inform people that they need to observe the rules. So those are the different namespaces that we identify that we need to cater for these different systems. So this is an example just to kind of like show you what that looks like. So this is an MQTT topic namespace. So this is an example for a milling machine that has got a raw namespace. So this is where, for example, you are going to be getting all these parameters: air temperature, process temperature, rotational speed, torque, and tool wear. These are the data points that are necessary for an AI model to perform inference. And these are the data points that are then published into that raw namespace for this specific milling machine. Now, this is what the inference namespace needs to look like, right? So again, you've got the milling machine. So as you will see here, the preceding elements from the milling machine are really custom. So there you could adopt, again, I alluded to the idea of the ISA 95 hierarchy where you've got site, area, line, cell, but this basically we sort of in a way are not kind of like standardizing on this. We're not defining that this needs to be inside the standard, but rather what we cater for is after that, where we've got the name of the machine that is supplying those data points, and then you've got the name of the model that is performing the inference. So this is basically, again, the idea where we're saying we've got more than one model in a device, so we need to specify which specific model is actually publishing this inference. So this is where the element after the machine name needs to be the name of the model. And then after that, we need to cater for the version of the model. So again, we need to track whether this is version A or version B of the model that is publishing this inference. And then this is, after that, you get the actual inference on this namespace. So this is what a namespace looks like. And then again, this is an example of what that could be. It could be a likelihood to failure or a likelihood to non-failure. That would be the inference that you get through that. And then this is an insight namespace. Again, you've got the name of the machine, and then you've got the name of the model, the version of the model, and the actual insight. So again, maybe the insight here could be maintenance is required. Right, so this is kind of like an example. Now, generally speaking, what we came up with then was that idea that the first elements need to be the customized MQTT topic structure. So this could be just one level of that structure where it could be an ISA 95 hierarchy, whatever makes sense, because this is kind of like really hard to standardize because companies have got different ways of really organizing their assets. But only when it gets to a point where we've got the actual edge device that has got these models is where we've got control over. So the edge device ID, which is the device that holds the actual model, is then followed by the model name, and then followed by the model version, and then followed by the edge inference. So again, this is a crystallization of what I spoke about earlier, and to kind of like represent it in a generic manner. This is what we came up with as far as the flat MQTT topic namespace is concerned. And then on the MQTT Sparkplug topic structure, this is what we came up with to say, so first of all, we've got the Sparkplug B root namespace. So this will be SPBV 1.0, or maybe if we get a next version of Sparkplug C, this will be SPBC, or whatever the case may be. This is the Sparkplug, right? And then for some of you already familiar with Sparkplug, you'd know that Sparkplug has got a group ID, message type, edge node ID, and device ID as a standardization of the topic namespace on how it should be represented. So what we then sort of like came up with was that the group ID needs to be that element that holds that custom structure that I spoke about. So it could be one level, right? Or it could be multiple levels. If it's multiple levels, you could sort of like use concatenation where you're fitting everything within that level using these delimiters. Or if it's just one level, you put your level there. And then you've got a message type. So most of these inference or most of these results are going to be published through a D data message type. Again, if you're familiar with the Sparkplug, you'd know what a D data message type is. But there's also support for other message types. It could be end data or command message type. So we do leave support for that. And then the edge node ID is what is the actual device. Or so, for example, it could be an IP camera or an edge server or a machinery where the models are running. So this is where you put the name of the device or machine where the models are running. You put it in the edge node ID. And then the device ID holds the name of the model itself, the AI model that is actually performing or generating that inference is what you put in the device ID. So this is how we sort of like mapped that into the Sparkplug topic structure in this case. And if you look at it on the topic structure on the unified namespace snapshot on what that would look like. So if you have used your ISA 95, you'd have site area line cell. And then after that, you then have that node, which is the edge AI hardware that holds those machine learning models. And then you would have the raw namespace, and then you have the AI models. And then after the AI models, you then have the version of the models and the for both inference and insight, right? Now, that was it for the topic structure recommendation. Now we look at the payload structure for this. So for the payload structure, we identified two basically edge AI outputs. So there's a prediction. So this is like basically regarding potential future events. So this probably would be like a linear regression model that is performing this insight. And then we also identified a structured insight where it would be like a classification. So this would be like maybe logistic regression, or it could be a neural network that is giving that insight, which is a classification that is extracted from an audio or video or whatever the case may be. And for the formatting of the message itself, the primary recommendation was that we adopt the protobuf, which is what Sparkplug natively uses as far as structuring the payload. So this is primarily what we kind of like really decided to kind of like use as the primary form of formatting the messages that get exchanged. But also we did cater for JSON. I think you'll see later on exactly how that would work, so that it's also compatible with JSON out of the box, even though it is primarily protobuf. So this is an example of a payload template for flat MQTT. So again, you see there you've got the model information, which is the identifier. So we do have the model information in the topic namespace, but then we also decided that this also needs to be within the payload itself, right? That information about the model needs to be in the payload itself. So that is the information. And then we've got the text, which is the source topic. Where is this information being published from? Again, this is important to put in the payload here. And then we've got the result type. So we also came up with different types that we cover. So this specific type is a class predictions, but we've got many other predictions or many other result types that you can find also on the GitHub, or I'll also show you a few of those later on. And then once you've specified what that type is, and then you actually then put the actual result. So the result will then have the class name and the score of that specific result. And then there's also provision to put in explanation if you want to explain how that model came to that realization, or whatever explanation you need to put into that. And then this is an example of a Sparkplug debeth payload that will be generated by a device that has got those models. So here you see the metric name. Again, for those of you who are familiar with Sparkplug, you know that the metric name, you could literally just use it to sort of like reflect a hierarchy. So basically, this is where then, if you remember, the device ID was the model name itself. The edge node ID was the device name itself. So, but we still need to have a way of kind of like identifying the model version. So identification of the model version, this is where it goes. It goes into the metric name as the first element of that hierarchy. And then after that, you get either an inference or insight. So you've got an inference identifier, and then you've got an inference version, inference name, all these different metrics that you get from the Sparkplug debeth payload. And then this is also just a quick snapshot of what that information would look like. Let's say if there's a Sparkplug host application that is consuming that information. So for example, it could be Ignition, SCADA system that is consuming that information. This is how it would look like within that Sparkplug host application, where you've got the source topic being reflected, the data type, the input, the result type, all of this just automatically being showing up on the Sparkplug, just by the nature of Sparkplug of being able to automatically discover this information. And this is a payload, a data payload, which pretty much looks like the debeth payload, but now with the actual values that are changing, right? And so I spoke about the result types that we sort of like came up with. So we came up with class predictions. We've got a whole lot of result types that we sort of like standardized on. So just to give you a few examples, this is a class prediction. We show an example of that where you've got a class name and a score, right? And then you've also got a multi classification, which contains multiple class predictions, right? So this is grouped into those different classes. And then we've got an object detection result type. So again, this is an object detection where you're detecting an object, you're specifying a score, and you're also sort of like specifying the bounding box. So I think this is what Mark is going to be using. This is the result type. So you're going to see a nice bounding box around or across his face there to show this is the object that has been detected and what's the class name of that object. And then there's the named entity recognition, and Yeah, without wasting more time, I think it's really now time to pass over to Mark the demo so to get a sense of what that looks like in practice, or what that workflow of integrating this into a live system looks like. So over to you,
That was
Mark.
a great presentation, Kojai. Yeah? Thank you very much, because I think it was very clear about all the work that you have been doing on the related with the newest standard that you're promoting. So okay, so I got the actually I'm here kind of by serendipity, because we had a call with Kudzai, and I was explaining a project that I was doing. I was challenged by an industrial company to see how they could use only one NVIDIA device with a GPU to analyze multiple pictures, instead of putting multiple NVIDIA devices that are very expensive with cameras for detecting quality, the quality of their manufacturing line, when the quality of the final product. So what I explained, what I was doing with Balena, of putting like Raspberry Pi cameras, and then just one device with GPU at the in the data center of the factory, and then using a broker, an MQTT broker, just to publish the pictures and send the results. So Kudzai basically explained me that he was working on these, and he mentioned, basically he gave me the name of what I was doing. He mentioned that I was doing this fully integrated pattern. So this is why now I'm with Kudzai, explaining these or demoing these. And basically what I did was, okay, sure, yeah, we need this standard or this type of framework to enable more people to do this, because I'm sure that other people is doing Edge AI and exchanging information over MQTT, and just reinventing the wheel, right? So I think it's great to have something that it's there, that it's solid, and everyone can basically participate. So here I'm going to show you a basic demo, basic example of quality assurance on manufacturing production lines, that it's following this fully integrated pattern. It's gonna run on Balena, and basically, yeah, I have a lot of devices. The machine learning model, it's not right now trained for industrial production lines, but yeah, we are gonna see if we can see some live data. So basically, yeah, I work at Balena. It's a bit of shameless plug, but maybe you already use some Balena software. I'm not sure if anyone from the people who's watching just use this or know what is this. Feel free to say in the chat something. But if you use this, basically you use software made by Balena. This is Balena Etcher, and it's a software that we made to enable our community to flash SD cards or USB drives to flash new operating systems on machines. And basically what we try to do is we try to reduce friction on anything that we do. But our main goal at Balena, basically, it's to create a container-based technology stack that you will see that it's open source, that enables any developer to develop and deploy software on IoT Linux devices, okay? And basically how we do that, it's in a really simple way. We think that the stack that works in the cloud can work on embedded devices, and this is what we do. We basically bring containers in edge devices. And to do that, you need to run an operating system based on Yocto that we basically manage to run containers on the top. That basically everything that I'm going to show, it's going to run on any Docker device. So everything is compatible with Docker. We add a security layer and some reliability. So that all the devices that I'm going to show you are running this Balena OS and are running containers on the top on this Balena engine, Docker engine that we built. And they run as well something that we call supervisor, which is an agent that communicates with our cloud system. As I mentioned, we have an open source stack, which on the cloud you can use something that we call Open Balena, which is our fleet management tool or device management tool for IoT devices that you can deploy on your server, or you can use Balena Cloud, which is our fleet management tool or device management tool, where you can manage your fleets of devices. Basically, for this demo, what I'm going to use, I'm going to use Balena Cloud. You can connect up to 10 devices for free. I'm going to show you all the source code and everything that I made. So if you have similar hardware, you can replicate it. But basically, it's what we do at Balena as well is that it's easy to do demos. It's easy to flash devices when they are on your table. But what happens when you are successful and you need to manage devices that are out there? So I like the Die Hard movies, and I like to go as an engineer. I also have this mindset that no worries, we will invent something and we will suffer a lot, but we will be able to update the software running there. Or I have this but deploy with Balena and try to reduce the friction when you need to update the software running on devices that are out there deployed. And not only software, but as well, for example, the operating system. If you want to update the operating system of your devices that are deployed out there, how do you do that? So this is how companies like Balena help you on the open source stack or the Balena Cloud Premium system. So, okay, what we are going to show you. So this is basically what I explained to Kutsai. So I have a Raspberry Pi with a camera. Right now it's a Pi 4 with a camera that it's publishing on an MQTT broker. Actually, last year on the same online conference, I was presenting something that it's called the Ming stack. And MIG stands for MQTT, InfluxDB, Node-RED, and Grafana. So what I show here, MQTT broker, basically, I have a Ming stack I'm going to show you. I have an x86 device on my table as well, that it's basically running MQTT, Mosquito, InfluxDB, Node-RED, and Grafana. And then what I have, it's an NVIDIA device based on the Seed Studio Recomputer J4012. This is basically an Orin, an NVIDIA Jetson Orin NX of 16 gigabytes. It's quite a powerful device. It costs a little bit less than $1,000, and I'm not sure about what can do, but it's pretty straightforward on what we are doing. It's basically running a YOLO v3 model to detect multiple objects on images. Okay, so basically the scenario is multiple cameras with cheap Raspberry Pis publishing to the MQTT broker, and just one GPU or one device with GPUs subscribed to that broker, to that raw topics that Kutsai was explaining before. And once they inferenced, once the NVIDIA device just detect the bounding boxes or classified whatever it's needed, publish the inference to the broker. And then the idea is that there is an HMI or a device subscribed on that production line that visualize the results. It doesn't need to visualize the image or the bounding boxes or anything. It just visualizes the results. As Kutsai was explaining, it's really interesting, all the different payloads and topics that are prepared to just simplify or reduce the friction of what you need to showcase to every specific step of this scenario. So basically, it's a fully integrated pattern, just to use the same image that Kutsai was showing before. So we will have multiple Raspberry Pi here running on Balena, basically taking images every X seconds, what we define by device variables on the devices that are publishing to the raw topic. I'm going to show you this in a second. Then we have as well an NVIDIA device based on the Seed Studio Recomputer J4012, which is an NVIDIA Jetson Orin NX, 16 gigabytes. And what do we have as an MQTT broker? It's an x86 device, and it's an Intel NAC i7. I think Intel doesn't manufacture anymore. Basically this can be managed by an ARM device as well. That's not a problem. But I'm just here trying to demonstrate that you can have multiple fleets with multiple device types, all managed with containers and with the Balena platform. Basically here, the square is not correct because the data transformation layer, basically it's Node-RED. For example, we could use Node-RED basically to do this data transformation layer and reformatting the data inputs if needed. In this case, it's not needed, but that could be one possibility. And finally, we can have a kiosk or a display, basically as a feedback control. Subscribe to the MQTT topic, to the inferences that the NVIDIA device is going to publish on the MQTT broker, just to visualize to the workers that are working on the production line the inferences that the NVIDIA device or the AI models are publishing on the broker. So I think we did a lot of theory. All of that I'm going to show you. I'm going to show you these GitHub repos right now. So the BelenaCam MQTT, basically it's an adaptation of BelenaCam project that instead of using RTSP or real-time protocols to stream images, I'm basically publishing to an MQTT broker. Then we have the Ming stack device with the MQTT broker I'm going to show you, and finally the NVIDIA Jetson device. So that's what I'm going to show you. So let's go to Belena. Wow, let's go to, in case that you missed last year presentation here. So this is the Ming stack that I mentioned. As said, so on Balena devices, it's only running Docker containers. So in this case, if you run a device with multiple containers, you need to run a Docker compose. As mentioned, I'm going to show you this on Balena, but this is also compatible with any Docker compatible system. So basically what I explained, we have a service called a container called Wi-Fi Connect in case that you change the Wi-Fi. So you change your device on location and it's not connected to the Wi-Fi from the new place. The device will become a hotspot. So from your mobile phone, you will be able to change the Wi-Fi credentials. We have Node-RED. We have MQTT. In this case, we are running an Eclipse Mosquito version 1.615. We just decided some specific versions to make these work perfectly in one click. And we have InfluxDB as well, a really old version, 1.711. And finally, Grafana. I'm only going to focus, even not on the broker. I have the device here, and basically, it's running, the MQTT broker and everything. If we go to the Node-RED, we can see, more or less the logs coming and going. I have as well a Modbus sensor here. I was trying to build a dashboard on Node-RED 2.0, but I didn't have time to do it. Sorry, just to show you the images in real time. But here we can see, for example, this is we received some raw messages from the camera, the Balena from the camera on MQTT, and if I'm not wrong, this is the inference, for example. Oops, but you can see more or less the messages going and coming. We have the BalenaCam MQTT, and basically, this is a simple. It's not a simple project, but it's basically deploying this BalenaCam MQTT. And the main difference is what I explained. What we do on this Python application, it's instead of sending the data to these streaming servers, basically we use MQTT. So we publish to the MQTTs that are defining as device variables on the device, and we just publish to the topic that it's defined as well. Or basically what explained Putsai as a unified namespace. We created some specific topics, and we use the raw topic here. And finally, we have, let me show you the BalenaCam. Basically, it's a Raspberry Pi. Oops, let me refresh this, no problem. It's a Raspberry Pi 4 bolted. It's connected to my laptop. And basically, if we check the logs, every X seconds we publish image to the topic of MQTT. And finally, the NVIDIA device, right, that manage all the, it's here basically at Balena. We made an example on the experimental repo that we have for the J4012 running PyTorch. Basically, this is an example running image recognition on YOLO v3. And basically what I did, I created a Python script called MQTT subscriber But basically what it does, it's not, I just change it for the one that it's on production, on running on my device, basically. But basically what I say, it's, check the device variable from MQTT broker, what's the port, what's the topic I need to subscribe, and what are the topics that we want to publish for the inference or results, etc. And basically, we publish, we detect the objects, and we basically define all the bounding boxes, etc., as we are going to say, as we are going to show in a second. So we have as well a database of all the objects that are detected. I'm going to try to do a live demo now. So it's, depending on the objects that this model detects, so we can see some things or the others. As this model, basically this YOLO V3 model, is just trained on casual objects that we can find at home. We are not going to show any industrial demo here. But basically, I have the device here. I'm running the model on the. I'm running these. Let me. Okay. Yeah, it's working. Fantastic. So it detects me and the chair. That and it detects me. So if I bring my glass of beer here in front of me, let's see if it takes it. So we see. Okay, we see a person, a sofa that is behind me, and a cap on 85%. Let's see the next picture. So basically, what it does, it subscribes to the topic, no, and we receive a message from camera raw. Now it detects a person, and basically afterwards, still detects. It says that it's a cap. It's a but basically, afterwards we publish this, the payload as it was explained before by Kutsai to the topic, and then the next device can do what it's needed. And I think we are running out of time, so so here it's just one example of what I was doing before. I try to put some objects behind me on the sofa, like a box or a bag and a drone or something, but in this case, it was detected me and the chair where I'm sitting. And I think we are good, right? Could say.
Yes.
Maybe just let's reinforce on takeaways that and how people can collaborate on all of this.
Oh yes, absolutely. Thank you, Mark. That was a fantastic demo. Yeah, so I mean the takeaways again here really is kind of like really to recap this idea that to promote interoperability and flexibility within the community, right, and between all the systems that we are working on. Really, we encourage collaborations from different companies, vendors, or individual contributors. So feel free to reach out to me, or you could reach out also to Mark if you want to be able to be part of this, and then we'll be more than happy to actually have you on board. So this idea again is so that we can actually build an ecosystem where we could build and deploy these applications so much faster and so much cheaper, because we have got all this interoperability laid out, and we're building up on top of the standardizations of specifications like Sparkplug that have already been built and give us this framework that allows us to then build up on top of. And also, Frederick, I saw you also sent it on the chat there a very important point that I omitted, that Sparkplug is actually now an international standard. So literally, we're building these systems on top of an international standard. So this really should at least provide some assurances to those who have maybe been doubting whether this is kind of like a future-proof way of handling this, but we're actually building on top of an international standard, and so is MQTT. So this is really useful, and really encourage everyone to join in here. Mark, you've got some last words?
Yeah, no, I think you did a good summary. Basically, looking forward to see other community members. I think we are in the right place to try to get more community members engaging on this standard, improving it, bringing new ideas and seeing what's next.
Amazing.
All yours, Serena.
Yes, Serena.
Awesome.
Thank you.
Awesome. Thank you so much. Well, I wanted to say thank you on behalf of everybody in our audience today for the excellent presentation. And a reminder, if anyone in the audience has some final questions, please feel free to ask them in the chat or use the Ask a Questions tab. I'll give you a few moments to do that while I wrap this up. So some key points here. We are looking to book more Edge of Things webinars. So if you're interested in presenting, feel free to fill out the form, which I have linked right now in the chat. So there it is. And lastly, we have some very exciting news. So the OCX 2024, which stands for the Open Community Experience, previously known as our flagship event, EclipseCon, is taking place on October 22nd to October 24th in Mainz, Germany. So the call for papers are open. We ask anybody that is interested in submitting a talk, please do so. You can find the link also for that in the chat. So it looks like, Mark and Kudzai, we do have 2 questions. And the first question comes from Frederick, and is, have you considered writing a companion specification to Sparkplug to formalize the kind of AI-related patterns you presented?
Yes, so thanks for the question, Frederick. Yeah, so I mean, we have considered kind of like really taking this forward to both the Sparkplug working group in the Eclipse Foundation and also to the MQTT OSs, but not in the we didn't consider it to be like a companion spec as it were. But it's good that you mentioned that that's a possibility, right? So it certainly would be something that would be interested in pursuing if that is a possibility, because I think it would be useful to have this formalized under Sparkplug and help other members discover it and also participate better. Yep.
Yeah, fantastic.
Okay,
If we can
great.
help, Frederick.
Awesome. And actually, that is the only question that we have here. All right. Well, thank you again both so much. We appreciate it. And we hope to see you very, very soon. Submit other talks as well. The knowledge and information and value that you bring to our community is exceptional, and we are greatly appreciative of that. Thank you both so much again. Talk to you
Thank
soon.
you so much, Serena, for